Hi, we're going to finish 3.1 now. I'm at home and my family's here, so if you hear noise and such, just ignore it and move on. So the section 3.1 is about derivatives, and the end of section 3.1 is all about graphing a derivative and the relationship between the graph of the original function and the graph of the derivative function. So try to keep in mind that the y-axis can act as either the value of the derivative function, or the y-axis can act as the derivative of the original function. So let's look at these right here. Excuse me. I'm on example 4. Given the graph of f, sketch the graph of the derivative on the same set of axes. Axes. All right, so you don't have this first one on your paper, but I want to do it anyway. If we were to think about the tangent line on this graph here, what would the slope of the tangent line be? Well, the tangent line would just actually follow along exactly on this line, right? It would be the same as the line. So what is the slope of the tangent line in this case? Well, it's the exact same thing as the slope of this line. And the slope of this line is, let's see, if I start here and go rise over run, 1, 2, 3 over 1, looks like it has a slope of 3. So my derivative graph would simply be a straight line at y equals 3. So that's my derivative right there. And this is the function right here. All right, let's look at the second one. So on this graph, there's different slopes. There's one slope here, another slope here, and another slope here. So we're going to have 4 different pieces of our original function. What is the slope of this part of the graph right here? 1, negative 1, 1, negative 1. It's a negative 1. So we're going to have a derivative function that is drawn down there. Now, don't worry too much about why I'm not filling in the hole right here, why it's not continuous. We'll talk about that a lot later. But for now, just realize that at any sharp point or corner or anything like that, the derivative does not exist. So let's see, what is this slope right here? This slope right here is going to be, let's see, 1, 2, 3 over 2. 3 over 2, which is a negative 1.5. So I'm going to sketch that as a negative 1.5 here. What is my slope here along this straight horizontal line? Well, it's a slope of 0. So if I were to graph my derivative, I'm graphing the slope again, so that would be 0. And then here my slope is 1, 2 over 1, 1, 2 over 1. So I have a slope of 2. There we go. So that's a piecewise function. So my original function here is just a bunch of straight lines, and my derivative function is going to be a piecewise function. Now, the last one on the page is a parabola. So the slope of the parabola is constantly changing. So it's going to be some kind of line or curve or something that's constantly changing. So if this is my function, what would the derivative look like? Well, if you start on the left and read towards the right, what is the slope through here? Let me sketch a tangent line for you. So if I picked a spot right about here and I drew the tangent line, it would look something like this. If I picked a spot about right here and drew the tangent line, it would look about like that. And so on and so forth. If I picked a spot right at the top, there's another one. Could have another one right there. So we need to look at the tangent line to tell us what the slope of the function at that point is. So looking at the tangent line here, what kind of slope is that? Well, it's a positive slope. And here along this area, it's a positive slope still, but it's approaching 0. I'm going to clean all this up later. Approaching 0. And then right here at the top, what is our slope? Right there at the top. What is the slope of that tangent line? It is 0. And then what happens to our slope as we move down here? Well, it starts off at 0 and it pretty quickly increases, and then it increases to a fairly large but negative number. What's that going to look like when we put it on the graph? It is going to look like a straight line. Let's see if I can get rid of these. Nope, not like that. So think about it again. Our slope is going to start off positive, go to 0, and then end up negative. So start off positive, go to 0, end up negative. That is going to look like some sort of straight line. I didn't actually calculate the slope, so I'm not sure if my straight line has actual correct values. I could draw a tangent line and get pretty close to an actual derivative value, but that's not what I was asked to do in this case. All right, we're going to look at this in class, hopefully. If you have time right now, go ahead and click over to it. It's a really good, it's got numerous examples of the slopes and graphs of f and f prime, the graphs of the function and its derivative. All right, let's look at example 5. Example 5 says, given the graph of f prime, sketch the graph of the function f on the same set of axes if you know that f of 0 equals 2. Why is it necessary to know this last part? Well, I'm going to sketch some points here for you, and let's think about what's going on. So remember, this is the graph of f prime of x. So this is a graph showing the derivative values at any x. So you may or may not want to sketch along with me right now. You can. There'll be a few changes, but it's nothing you can't just add to your graph. All right, so what would the derivative value be through here? Well, as x goes from, I don't know, -6 or so, all the way up to positive 1, the derivative value is -1. That means the slope value is -1. So let's draw a line with a constant slope value of -1. Because it would be a constant, right? Because this line right here that I'm pointing to, not the one I'm drawing, the one I'm pointing to has a constant y value. So therefore your derivative or your function graph needs to have a constant slope. All right, did I graph -1 correctly? Yes, that is a slope of -1. Okay, then what happens right here? All of a sudden your slope jumps from being a -1 slope up to a +2 slope. So what is that going to look like? Well, all of a sudden you're going to have a line that does something like this. I think that's a +2 slope. Hopefully you agree with me so far. Now let's look back at the problem. What does this mean right here? Sketch the graph of the function f if you know that f of 0 equals 2. Okay, that means, what does that tell us? That means when x equals 0, y has to equal 2. That means that we're going to have a point right here. So we need the exact same shape graph, but this time we need to double check that it goes through this point right here. Let's see if I can graph this. Kind of messed it up right there, but I think you get the gist of it. Okay, so why is it necessary to know the last part? Well, it's necessary to know the last part because otherwise we could have drawn just countless, infinite numbers, in fact, of essentially a V on our graph. But by narrowing down this point right here, they gave us a frame of reference. And they not only do we know what the slope of the graph is going to be because we are given the derivative graph, but now we know an actual point on the graph. That nails it down where we're going to be. All right, let's look at the last example. Example 6. Suppose the graph below is the graph of the derivative of h. Okay, so this parabola right here is a graph of the derivative. So this is showing the slope at any time of the original function. What is the value of h prime of 0? What does this tell us about h of x? Okay, well, h prime of 0, this is a graph of h prime of x, so don't let that confuse you. H prime of 0 is simply your h prime value when x is 0. So that's just simply this point right here. So the answer for that would just be h prime of 0 equals 4. What does that tell us about h of x? Well, it tells us that at x equals 0, the slope of h of x is going to equal 4. Let that sink just for a second. Okay, let's look at b. Using the graph of h prime of x, how can we determine when the graph of h of x is going up or going down? Well, keep in mind, this is a graph telling us the numerical value of the slope, and those are the y values here. So, like for example, right here, this is a negative y value, right? I don't know, it's negative what, 6, 5? Right here, we have a negative y value. Right here, we have a negative y value. Right here, we have a y value of 0. Right here, we have a positive y value. Positive y value, positive y value, positive y value. Even this right here is a positive y value, positive y value, positive y, y equals 0. Negative y, negative y, negative y, negative y. How does this help us? Well, let me try to summarize it. This tells us when h prime of x is positive, I'll outline those here. When h prime of x is positive, these are all positive y values right here. When that happens, you know that h of x will be going up. It will be increasing. It will have a positive slope. It will look like this of some sort. It will have a positive slope. Okay, and then what about when it's going down? So when h prime of x is negative, which, let's draw that. Come on. That would be all these values here, and that would be these values here. So when that happens, h of x will be going down because it has a negative slope. The y values are negative here. That tells you that the slope of the original function will be negative. So when you have a negative slope, you're heading in the down direction, bottom right. Okay, let's look at part C. The graph of h prime of x crosses the x-axis at x equals 2, right here, and at positive 2 and negative 2. Describe the behavior of the graph of h of x at these points. Well, what that means is if h prime of, we'll say, 2 is equal to 0, and h prime of negative 2 is equal to 0, what does that tell us about h at 2 and h at negative 2? It tells us at these places right here, the slope is 0 at those places on the original graph. Are you curious what it's going to look like? Well, it's kind of hard to graph just because it's a little messy, but let's look at it. So we know that at x equals positive 2 and at x equals negative 2, we're going to have a slope of 0. When do we have a slope of 0? When we have some sort of horizontal tangent line, when our tangent line is a horizontal line. That happens at either something like this, right here at that point, you have a horizontal tangent line, or maybe you have a curve going this way, and here's your tangent line there. Again, you would have a slope of 0 at this point. Excuse me. So if you start off here, when your slope is negative, and then your slope has to hit a point where the slope is 0, and then all of a sudden your slope is positive, what is it going to look like? Well, it's going to do something, oh goodness, like this. Sorry, that was a curve. It is not perfect by any stretch of the imagination. All right, so your graph, think about what's happening here. I'll kind of color it on the green as well. So through the green area, through here, you have a negative slope all the way down to here. Now, right there where the big blue dot is, I'll put a big blue dot here. That is where, I don't know why it's doing that. Oh, I know. That is where, right here, we have a slope of 0. Now, through the yellow area, through this part right here, our h prime of x is positive. That means our original function has a positive slope. And then what happens here? Well, the h prime of x crosses 0 again. So our slope, once again, the slope of the tangent line is a 0. And then, of course, we finish here with, oh, that was supposed to be green, with a negative y value for the slope, which means the slope or the line is going down. So it'd really be kind of a smooth curve. That's not a very good picture, but hopefully you get the gist of it. Okay, that's it for 3.1. I will try to get 3.2 up as soon as possible. Your homework, again, was the entire front of the sheet plus number 6. We will talk about this graphing stuff in class. If you want to get started on that, you are welcome to work the other problems on the 3.1 worksheet. All right, we're going to do quite a few little hands-on things, hopefully, with the graphs of functions, because it is a little bit confusing. Okay, if you have any questions, please let me know as always. Bye.